All right, so this right here is my insanely powerful ZFS video editing file server. And I want to give an overview of it and kind of open it up because it's changed a lot. And I really want to talk about the great things that I've added to it and some of the best parts about it. I also had a top cam out for some other things. So I figured while it's already out and set up for this thing, I may as well talk about the components in here and how it's worked throughout the past few months. Because I've been using this thing for two real main use cases. So right now, this is the video editing file server. So the first of these 8 bays are currently filled with 1 terabyte SSDs, SATA SSDs, super cheap ones off of Amazon. I'll leave a link to those, nothing special. And it's got 256 gig boot drives for the actual boot pool. And then on the back right here, I've got a total of 4 different HBAs. So the first 3 you see right here are all internal HBAs. That's because the actual chassis that I'm using from Supermicro is one of the versions, and you can get them in any single version you like. But this is the version I'm using that actually does not have a SAS expander on there. So that means that every single one of these 24 ports up front, they're all SAS 2, and they're all brought directly into an HBA. So each HBA can handle 8 SAS drives, and so we have 3 HBAs back here. Then we have an additional HBA that is hooked up to the external SAS JBOD that I've got set up for my overall hard drive storage. So this is actually dual storage. It's both SSD and HDD, which is a really nice thing to be able to do. And I can just add space as I need. And another really nice thing I can do with it is I can take snapshots often and replicate them from the SSD drives up front to the hard drive volume. And so that way, I can easily store up a bunch of previous versions of files from the SSD editing NAS without having to deal with all the space on the actual SSDs. And since I've got 96 terabytes of hard drive space, I can just store a bunch of previous versions of the actual editing file server just in case I ever need to go back to something and say, oh no, I accidentally deleted that. Oh no, I need to do this. I can keep those for a long time because I've got a lot of free space in here and they're not taking up the expensive SSD space. Another thing that I'm finally adding in as well for that hard drive pool is a layer 2 ARC. And if you've not seen my video on layer 2 ARC, you'll actually see me installing it here. You should absolutely go check that and I will put a link to that in the description. But layer 2 ARC is a phenomenal thing for a hard drive pool, especially for my kind of workflow. And especially now that they've got persistent layer 2 ARC between reboots. So then the system also has 128 gigs of RAM, which is absolutely awesome for ZFS, especially for something like a video editing file server, where the majority of time it's just able to cache so much of the files that I'm using while editing just in RAM, so it never even has to pull from the SSDs. This system is absolutely overkill for the 2 editors, myself and my wife Katie, that are ever actually hitting it. I do boot a fair amount of virtual machines from it as well, and really I use this as a test bench for client systems when I'm going in and saying, all right, is this going to work out the way I want it to? It's much better to test it and fail here with my own data and my own system than when I'm setting something up for a client and they're spending a lot of money on it. I can kind of validate everything here, and it's great to have a test bench. Then for the network card, which is by far the most important piece about a NAS, I have a 25 gig NIC that hooks up to a 25 gig UniFi switch that I've got. And so it is absolutely just a powerhouse. But at the same time, I had some real issues with this system when I first built it that were incredibly hard to detect. Honestly, because ZFS is so powerful. But I had some insane performance issues that it took me actually I want to say almost 2 months to really be able to fully diagnose. And that was these cards. They are the LSI 920s. They're the LSI PCI 3.0 SAS 2 cards. I will leave the actual model number down in there. And these cards with this backplane and these SSDs, I could not for the life of me figure out what combination of those 3 things were causing the issue. But they would throw these weird interrupts as far as I can tell. And so when I was doing sequential reads from the actual SSDs up front, they would go insanely slow. And I mean insanely slow, like 1 or 2 megabytes per second. And the reason it was so hard to diagnose was it has so much RAM in here that doing a pull from it was almost always in the actual RAM. And so it would just be weird times where I was detecting performance issues. I tried everything. I tried doing pools with one SSD, two SSDs, and then they were fine. And then once I had the third or the fourth, then it would start interrupting. I tried the ports. I tried every single combination of everything I could think of. I flashed the firmware on every single one of these HBAs probably 6 times, trying to find a firmware that would work. I had ZFS boot arguments. I had FreeBSD boot arguments. I tried everything under the sun. And then finally, I tried TrueNAS Scale, and instantaneously, every single one of my problems went away. And it's for that reason that I believe TrueNAS Scale is the future of the TrueNAS project. So let's quickly talk about what TrueNAS is and what TrueNAS Scale and what TrueNAS Core is. So TrueNAS, I'm sure you've seen it, is basically a NAS operating system that's completely open source that is entirely centered around ZFS. Phenomenal file system. It is maintained by a company called IX Systems, who sells very high performance storage based off of the operating system, but you can completely download it and build it yourself. It's completely open source. So for the longest time, it was FreeNAS, and it was all based off of FreeBSD. If you don't know what FreeBSD is a Unix-like operating system. It is a cousin of Linux. Funny enough, macOS is actually very similar to FreeBSD because they were both based off of BSD way back in the day when Unix-like systems were popping up left and right. But essentially, it is a cousin to Linux is the easiest way to explain it to somebody. And so when you think about FreeBSD, you can think of it very much like the way you think about Linux. They're cousins, they still have the same open source thought process, and it's kind of set up the same way overall. They are pretty indistinguishable to the layman who does not really understand them. You can SSH into both of them, and it all feels relatively similar. FreeBSD is not as popular as Linux, and I'm going to talk about that a little bit here, and that does have a downside. But one of the real advantages to FreeBSD is it is incredibly stable and incredibly efficient, and it is also designed to be very customizable to a workflow. All of these things made it a perfect target for a NAS operating system like FreeNAS, which became TrueNAS. Then about 2 years ago, IX Systems, the shepherd of TrueNAS, announced a new project called TrueNAS SCALE. TrueNAS SCALE is TrueNAS, but based off of Linux. It inherits all the great ZFS and customization that is built into TrueNAS Core, but is based off of the Linux kernel. And so that has a few really great advantages and a few disadvantages. The biggest advantage of it is really twofold. One, Docker containers. FreeBSD was actually, I believe, the first real operating system to include containers. They were jails at the time, and so they were kind of the first to the punch. But then Docker came along, and Docker kind of took the whole container world by storm. And so because jails only work on FreeBSD systems, and there's not a ton of FreeBSD systems out there compared to Mac, Windows, and Linux systems, Docker containers have exploded in growth, whereas jails just have not. And so to add in the ability to have Docker containers, they moved over to Linux. The other huge advantage that cannot be understated and why I am running TrueNAS Scale is hardware compatibility. Linux just simply outweighs FreeBSD when it comes to operating systems. Way more people are deploying Linux before they're deploying FreeBSD. And so one of the things about that is companies, if they're going to build an open source driver for Linux, they might not do that for FreeBSD just because, well, it takes a long time. And so the base is just smaller. And so the issue I was having was with enterprise grade hardware, which just for some reason had an issue. And so that is one of those things where as soon as I switched over to running TrueNAS Scale, which is the Linux version of TrueNAS, that issue went away because the drivers for these HBAs just apparently had fixed that issue and had not had that issue. I still to this day cannot figure out what that issue was. But I know as soon as I change over to TrueNAS Scale, the issue went away. Another big thing is drivers for something like your network card. A lot of network cards do not have great drivers on FreeBSD, and those that do tend to lag behind in age. And so one thing you have whenever you're deploying a FreeBSD system is you have to make sure your network card has the actual driver for it. When you're deploying a Linux system, it's still not as good as Windows probably, but you're very likely to be able to have a driver just because so many high performance systems run on Linux. And so it is just defaulted there. And so that is the reason why today I am running TrueNAS Scale. And TrueNAS Scale has some real advantages. The virtualization is far superior to that of TrueNAS Core because, quite frankly, Beehive is not that great of a hypervisor compared to KVM, which TrueNAS Scale uses. And so because of all those reasons, I've been running TrueNAS Scale on this system, and it has been working great. A couple of things I don't love about it are the fact that you don't have any way to have boot arguments. FreeBSD is so customizable. You can have these things called system parameters that essentially just get applied at boot and can control all these different parts of the system, whereas Linux just does not have that. And so I have to set parameters manually. Another thing that Linux does, specifically ZFS Linux does, is because of a specific possibility of RAM not getting deallocated quick enough, ZFS on Linux decides to only allocate half of the available RAM to ZFS. When you're running FreeBSD, that is 95%. And so this is because, due to a specific technicality, the RAM on Linux, and I do not fully understand this, might not be fully deallocated when it says it is. And so because ZFS is stable first, speed second, they decided to say, well, technically the maximum, the worst case possible scenario could be that 50%, basically 100% of the RAM is deallocated at once. And so we have to go down to 50%. And so that is one thing by default, you'll notice your RAM is only 50% used on there. So I actually, every time I boot the thing up, I set it to use 80%. And I've been doing that for a long time as testing, and I've not once had an issue. And so I feel comfortable recommending that. Once again, I do have 128 gigs of RAM, so there's a lot of play around room for that. But I have not had an issue at all with that, though once again, validate it on your systems. And so that is one real disadvantage of TrueNAS Scale. But overall, this system has been phenomenal. It does draw a fair amount more power than my Dell R630, but it just has a ton of performance over the system. One thing I did go, and I'm very glad I did, is I went single CPU AMD, just because something like a file system really does not need that many cores. I do have 24 cores on this system, long story. But not having two CPUs means you don't have to deal with NUMA issues, and so you can get much better performance out of a system like this than if you had two different CPUs in it, because it's constantly having to send data between the two CPU cores. But if you only got one, you can just bypass that issue. And generally, ZFS and SMB and the majority of systems, you don't need a ton of threads for it. So it's not even having that many processes. So even with compression, everything turned on this thing, I'm never using that high of the actual CPU. And so it's honestly way over spec'd, and I probably could have gotten better single client performance by speccing into a lower but faster CPU that just had fewer CPU cores on there. But overall, this system has been absolutely awesome. And I now want to go ahead and plug this thing back in. I'll show it in the server rack. And I want to kind of talk about a little bit of my workflow using this system and what the advantages to using it have been for me. So I'm going to go ahead and put this thing back together, spin her on back up. All right, so now just gone ahead and booted up my machine and we can look at it. And the first thing I want to show are a couple of the custom parameters that I've been using to make ZFS run a little bit better for my use cases. And so as I said earlier, ZFS is only going to use half the RAM on Linux. And I'll leave a link to the article about why that is in the comments below. But in all honesty, that makes sense for leaving like 10 gigs, but not the entire thing full. At least from my own testing, I was not able to find an issue with it. And so the thing about ZFS is it's always trying to be as safe as possible. So what's going to happen is I just went in and opened up a project over here, and we're going to see it use a lot of the RAM. So it's going to very quickly fill up with RAM, and it is going to stop at halfway full. And anybody who came over from TrueNAS Core knows, hey, something weird's happening if that's the case. And so the way I get around this is you can actually just set it manually. So I'm going to go ahead and set that to use all 100 gigs of RAM. So that way I will still have 25 gigs of RAM left for everything else. So it should be low risk, but it gets me an extra 40 gigs of RAM utilization. Now, at least as of right now, I've not figured out a way to be able to actually do this on boot. I tried to a lot of different ways, but there's no way to like kind of get these settings persistent between them. So what I do is every time I reboot, I've got 3 scripts right here that I just run. Theoretically, I think syscontrol is supposed to be able to do that, Or maybe one day I'll just add a cron job that does it on a loop every hour or so. But for now, what I do is every time I boot up, I just come in here, copy these, and execute them. So I'll just take all of them and paste them into terminal. And what this first one does is it does 100 gigs of RAM in the ZFS Arc Max. Then what this one right here does, and I can copy these down in, is it makes sure we have at least 30 gigs in the Arc. I don't think this is that useful. I still do it though. And then finally, what I actually really like doing is this one right here. This one says, hey, metadata. ZFS, do not get rid of metadata until you have at least 8 gigs of metadata in your Arc. And this one is crucial because I've got 128 gigs of RAM, or the Arc, and the Arc's gonna have 100 gigs of RAM in there. 8 gigs is nothing, but if I have 100% of my metadata in RAM at all times, you're gonna have a great experience. Listing folders by size happens instantly, and so many things like that are really, really accelerated, especially when you're indexing files. So doing like rsyncs are really sped up. So this is one that I really wish they would tune a little bit better to maybe ZFS Arc metadata min, maybe instead of it being a actual value, it could be a percentage of the overall Arc. Because if you have over probably 30 or 40 gigs of RAM, you may as well allocate pretty much as much of it as possible to metadata, because metadata takes up very small amounts of space. And if you can, you may as well have it in there. So those are my 3 ones I have in there. Once again, do these at your own risk. So that is some of the stuff. And so now when we come in here to the dashboard, as this project loads in, we should see that the RAM is going to continue on past halfway full. So as you can see, our Arc, our ZFS cache is already above 50% utilization, which means you know it worked correctly. Then we can come in and we can also check out my NVMe Layer 2 Arc. Really, I don't use this a ton. This hard drive pool is really not used that often, so it's not a have to have. I mostly have it in there because I do a lot of testing for video editing, and specifically for video editors. If your backend is for hard drives, having a couple of NVMe SSDs as Layer 2 Arcs is absolutely awesome. You can get SSD-like speeds from a hard drive pool, especially once the cache is warmed up. It can be incredibly effective of having terabytes of storage while also having incredibly fast access to them. So that is awesome. Now the way my pools are configured is pretty basic. So the hard drive pool and then the SSD pool. So my SSD pool has 2 RAID Z1 arrays of 8 drives each. And I have 24 ports, so I could technically add another 8 drives in there and make this 24 SSDs wide. Probably overkill, definitely overkill, but with how much I've got in the backlog right now, there's a ton of data used in there. And then right now, I only have my hard drive pool half full. So the JBOD I've got has 16 ports, but I've only got 8 of them in there. So once again, that is a RAID Z2 array consisting of 16 terabyte drives with 8 of them right now. And I could double that to 16 drives for even more space, which gives me 96 terabytes, which is 82.62 TB of usable space. Then the way I actually go in and do that backup from my SSD volume to my HDD volume, or pool, sorry, is I actually use a replication task. So we can see that I've got snapshot backups right here that are always being sent over. And you can see edit backup is 10 terabytes or TB, whereas edit right here is only 7 TB. That's because this has a lot of previous versions of files that this one on the SSD does not have. And so that's really easy to set up over here. Under data protection, it says pending here for all these different snapshot tasks. But right here, I've got this replication task. And this is very simple. What it does is it takes edit from SSD. This is where I'm video editing over here, and it's all on the drive. And it's on the SSD volume to get the best possible workflow. Then every hour, it is snapshotted over to the actual hard drive pool. And the hard drive pool has a much longer time that it keeps them for 10 weeks. And so that way, if I ever needed to, if I ever realized I deleted footage or deleted a project or did anything that I needed to get back to, I could recover that footage for up to 10 weeks from the hard drive pool. And so it's really nice to have. Or if anything happened and say my SSD volume entirely crashed, well, I could easily switch over and actually, without moving a kilobyte of data, start editing from the hard drive volume and just change that to my edit SMB share. And that way I can keep going without having to recover multiple terabytes of footage if I'm in a pinch. I highly recommend setting this up for anybody who's working professionally. And I set this up for a lot of people. It's phenomenal. Then as you can see, I've got some pretty complex snapshot tasks here. They're very, very useful. As for my network cards, I've got two 25 gig ones in here and multiple VLANs associated with them that I'm not going to show for just, well, general security reasons. But I've got a lot of different VLANs that I've got to set up to segregate off different bits of data for different clients and things like that, just to kind of make sure that if anything ever did happen, just if I'm ever attacked, it would limit possible exposure as much as possible. It's always best whenever you're designing a system to always limit access to only what somebody needs. Even if you think, oh, I'll never get hacked, it's much better and easier to start where you only give things the access they need. And then as they need it, you can give them more access. And that way, from the beginning of your design, you have a very secure setup and it's much easier to implement when you start than when you get really big and you're like, oh, I got to redo 1,000 systems. Instead, they're built up from the beginning. I'm not running any virtualized machines in here or any of the Docker apps, but I do really enjoy the reporting metrics through here. As you can see, we're having a lot of reboots today, having a lot of fun. Then the way I'm accessing files on this NAS 95% of the time is SMB for any computers. So for example, basically any computer for video editing is all over SMB, Time Machine, all that kind of stuff, all over SMB. Then for my Zen Orchestra and server to server and things like that, I use NFS. So this right here is NFS for the actual virtual machines. So I have some virtual machines that boot right off of this right here. And then the backups are also using NFS and backed up here. I use Zen Orchestra. I've got a video coming out for that. It might be out by the time you watch this one, where I actually use Zen Orchestra to back up to the hard drive pool over here. And so that way I've got really, really, really great backups of that data. If you pull up my data set over here, this Zen Orchestra backup is absolutely phenomenal and it's really easy to recover from. Though I have a lot of versions clearly in this. Oh, I am snapshotting there. Yeah, it should not be 4 TB bytes. It should be much less than that, but that's fine. Then I also back up using rsync. I've got a tutorial on how to do that. This right here, FSO1, is my Synology. And so I back up the entire thing or all the crucial stuff in here every single night, which is very useful to have. And I also use Time Machine. Time Machine on ZFS, with the metadata never being evicted from ARC, like I talked about earlier, is insanely fast. It goes from taking forever to run a Time Machine backup to happening incredibly quickly. It is funny just how different in terms of performance those two things can be. And overall, that's pretty much the gist of this setup. I really, really enjoy having it, and it works really well. I definitely do run into odd use cases, especially sometimes you update and just weird things happen. But overall, I've never felt like the data was at risk. ZFS is just so rock solid and stable, though sometimes the updates from TrueNAS SCALE can have issues. For example, just before this video, I updated my TrueNAS SCALE instance and had a ton of huge performance issues, and so I had to roll back. Thankfully, rolling back with TrueNAS is insanely easy by design. There's these things called boot environments where if I need to, this was right here, this was when I updated, and then I found that the update did not work. Well, I could just restart back from my old version and not lose a beat. I'll leave a link to a couple of the other home lab tutorials I've got where I show setting this thing up. But go ahead and leave any of the tutorials you'd like to see me make in the comments below, and have a good one. Bye!